I'll just start right off the bat. Thank you very much for this opportunity. Let me start by giving you a brief background and introduction about myself. My name is Gaurav Shorey, and by qualification, unfortunately, I am an architect. I say unfortunate slightly specifically because if you go by the IPCC reports back in 2009, 2010, third assessment report, I recall used to say things like 80% of the carbon emissions attributed uh, at the level of the globe are attributable to cities. And when we think of cities, what do we think of? Buildings and roads that connect the buildings, right? And then who designs the buildings and who builds the buildings? It's architects. So very interestingly, I have this existential crisis that I have to deal with on a daily basis. That by qualification, I'm an architect. I also, by virtue of being an architect, I also have the ability, or I've been trained to be able to visualize things at a microscopic scale all the way to the city or even at the level of the country. So I can see the kind of impact that buildings are likely to have on the environment, given the situation of climate change and global warming, etc. But that thing, all things aside, I've spent the past 16 years working in the domain of sustainability. Six of which was spent spearheading something called Griha, which is India's national rating system for green buildings. And I remember at that time, it was a huge privilege to work in an organization like Terry, because we had multiple departments. We had departments that dealt with forestry, departments that dealt with city planning, departments that dealt with climate change. And one could actually go and directly interact with experts and understand what is the situation and what is the problem that we're dealing with. And at that time, I realized that a lot of sustainability initiatives that we think are attributable to the West or attributable to the international sensibility are not. Actually, they're not even applicable to the Indian situation. Because if you look at India as an entire country where literally 68% of the population lives in rural or tribal areas, their carbon footprint is much lesser. Their lifestyles are way greener. The way they build their buildings are way cleaner. I'm not saying that that's necessarily not changing. It is changing very fast. They're aspiring to build like city people. I don't think if that's a good thing at all. But that journey helped me realize that we might just be barking up the wrong tree. And in India, we need to revive faith. In India, we need to have Indian people believe in themselves, believe in what is ethnically and traditionally theirs, and not constantly look at what's the US doing, what's Europe doing, what's England doing, what's Germany doing. Not required. They have very different climatic contexts, they have very different socio-economic contexts. They have been capitalist countries for a very long time. We have not. Now, what have we been? I don't have an answer to that, but perhaps this study that I'm going to share with you today will shed some light on the kind of impact that our choices are likely to have if we blindly copy what is happening in the West. Now, I just wanted to inform you that I'm working on two screens. This is my big screen and this is my small screen. So in between, if you see me turn my head over here, don't worry, I'm not talking to anybody else. I'm just looking at my other screen momentarily. All right. So what I'm going to share with you today is the work done by students in the School of Planning and Architecture, where I've been teaching now for 10 years, since 2010. So this is my 11th year now as a visiting faculty. And it's had me um, rediscover sustainability inside of the questions that my partners in SPA ask me. I don't call them students, not really, because we're on the same journey and it's a professional program. So what I'm going to share with you today is work done by them. It has been done over the past 3 years. It's a rudimentary study, but it's decent enough to have you understand what is the impact of architectural decisions and material decisions on the environment. All right. So as you can see, the title is called "What Lies Behind Green," because I do think that there are a lot of lies behind the way green is sold to us and what green really means. So without much further ado, let me take you to this study. So this study is based on a very simple scenario analysis. The results were very unexpected for me as well as the students who were doing the analysis. My intention in the classroom, I essentially teach HVAC systems, green systems integration, rating systems, national codes and policies to do with green, so on and so forth. I was trying to explain to the students the concept of global warming potential and embodied energy. And fortunately for us, we discovered the International Finance Corporation database, IFC database methodology report that was launched in November 2018. And this is a very interesting report because they've detailed out a methodology by which they were able to figure out, they were able to calculate what is the global warming potential, the carbon CO2 emissions equivalent per kg for various building materials across India. And they've explained how they've gone about doing it. My invitation to you would be to just Google it. If you just Google IFC database India, that's the first report that you'll find. So please download it and go through it. So what we did in class was to try and understand if we took a tiny building, okay, we're talking about 150 square meters, that's 15 meters by 10 meters, really, really small building. And what we tried to do in that building is take the basic broad brush materials that we use anyways. uh, should be coming up on your screen right now, and just analyze what is the global warming potential of those materials, right? So we look at, what do? We have a structure that is made out of RCC. We've got brickwork for the exterior walls. We've got glass for the windows. If there's a chhajjas or shading devices, it's again RCC. And then we've got some aluminum frames in a conventional building. And we didn't go into detail. Like, we didn't go into interior materials and surface finishes and paints, even though all that is mentioned in the IFC database. We kept our study simple because I didn't mention this before, but I'm doing this with, you can visualize me doing this with third year students. All right. So we did this calculation where we said, okay, brick, RCC, glass, aluminum, and cement plaster, simple cement plaster finish. And we realized that if you take a 40% window to wall ratio, which is recommended by the Energy Conservation Building Code, then what we get in terms of CO2 emissions is 174,191 kilograms CO2 emission for a business as usual case. Business as usual cases, this is not a green building. This is a conventional single glazing aluminum frame, brick wall, 9 inches kind of situation. Now, next thing that we did was we decided to do the calculation again. This time, all we needed to do was change the materials and change the emissions factors, right? And it was phenomenal. Like, we were really excited when we saw the results that, wow, look at this, man. I mean, the results have come from 174,191 to 102,000, 102,625. And this PPT, which, if I can share it with the Ethos group, can go on to be shared with you as well. If you see the bottom right corner, there is an Excel sheet. And that Excel sheet actually has the calculations. So you can open the calculations yourself. You can vet the calculations. You can see if we've made any mistakes in the calculations, though we've run it past more than 100 people so far. So I think we are all right on the calculations. But essentially, what we did in the new building was that we replaced bricks with pulverized fuel ash or fly ash blocks. We replaced it with insulated walls. We doubled the glass from single glazing to double glazing. And what that brought to the front were some very interesting findings. Number one, we discovered that if you look at the second last column on the right side of your screen, sorry, this will be the right side of your screen, then you will notice that the global warming potential in kilograms CO2 equivalent per kg of material is given. And you will notice that aluminium is the highest and glass is the second highest. Now, incidentally, what happens in a green building is that we go for double glazing, or we go for even triple glazing if you're going for very high performance buildings, for example, under the passive house system. That doesn't necessarily bring my emissions down. As a matter of fact, as soon as I start bringing in insulation material, say for example, rigid foam or bat insulation or XPS, again, you're talking about global warming figures that are to the tune of 12 kg CO2 emission equivalent per kilogram of material manufactured. So we did realize that on the whole, the numbers were coming down. And when you put it into a graph, it looked absolutely stunning. It was like this. So you had red, which was the business as usual case, and then you had green, which was the green case. Like, wow, this is phenomenal. This is a 41% reduction. This is isn't this great? Let's do a double take. All right. First thing I wanted to show you was satellite images of our cities. And these are all our cities. I'm talking about Bangalore, I'm talking about Chennai, I'm talking about Pune, I'm talking about Hyderabad, I'm talking about Ahmedabad, right? And yeah, this is Mumbai. You recognize these cities. I mean, when you see their satellite images, this is what these cities look like. And what is interesting about all these cases is that it's very apparent what the density of construction is. It's very apparent what the density of development is, right? Now, if I was to make a green building in this situation, then number one, I'm putting a drop in the ocean. And I think that the metaphor is fairly clear. It is an ocean. And that ocean right now is expanding like crazy. All right. So being an ECBC master trainer, being one of the first trainers in the Griha system, I have trained more than 20,000 architects and engineers in green building systems by now. If I'm not under calculating it, the number might be higher, but definitely not lower. And over the past 16 years, I still find myself in a position where architects and engineers don't know the fundamentals of green. Like, what is the basic, why should you modify the orientation of a building? Because the National Building Code in Part 8, Section 1 tells you to. It gives you the tables of insulation values. It gives you the tables according to which you should locate your building openings. SP 41 1987 tells you exactly how to locate your windows for natural ventilation, or what should be the size of a courtyard to facilitate stack effect. It is given in our national codes. But unfortunately, this is not common knowledge. Uh, Now, I don't know whose part it's a failure on. I will take responsibility largely for not being successful in advertising it or in not propagating it well enough. But we are still stuck with the ocean. The ocean grows bigger and bigger. So if you go to Google Earth and use the time slider and try to see how the city of Delhi or how the city of Bangalore or how the city of Hyderabad have expanded, and where the Kundli Manesar Expressway is right now in Delhi, or where the outer ring road is there in Hyderabad, you're talking about cities that we have no clue what kind of energy and resource consumption these cities are going to have. Now, that's a separate issue. What I'm highlighting over here is that if I was to build one building and to make it ECBC compliant or Griha compliant or IGBC compliant or whatever your choice of rating system is, though I must make this distinction that the ECBC is a mandatory code, it's not a rating system, which is voluntary. So in this case, the case study that you're looking at right now, we made a ECBC compliant building, not necessarily a Griha or an IGBC compliant building. This is the graphical result. But the only thing that's missing in this study, which is the little gap that we bridged, was via a small little exercise that I want you guys to participate in. All right. And parallelly, I would like you to Google all these questions for yourself so that you find the answer for yourself. So don't believe a word that I'm saying. All right. I would suggest that you actually do this digging yourself. Here's the questions that you need to answer right now. Number one, what is the CO2 absorption potential of a large canopy tree? So you can actually Google CO2 absorption large canopy tree and you will get the answer. The topmost result that Google will give you, and believe me, I've done this several times with several audiences across India, is this little excerpt that comes up right on top, and it tells you that a typical large canopy tree can absorb 48 pounds of CO2 per annum. So you take 48 pounds and divide it by 2.2 and you convert it into kgs. So you get 21.8 kgs per annum is the CO2 absorption potential of a large canopy tree. All right. Uh, Second question, what is the radius of a large canopy tree? Now, this is a very interesting aspect that most of us don't even realize, that the Ministry of Environment and Forest has this clause in the environmental clearance criteria that if you have a site, then that site, every 80 square meters of open area, you need to have a tree. Obviously, they've not done their maths because typically a large canopy tree will have a radius of about 7.5 to 10 meters. I'm talking about radius, I'm not talking about diameter. All right. 10-meter radius after at least 20 years of growth, right? How much area does that translate to? Which is actually incidentally the next question. How much area does a large canopy tree occupy? So all you need to do is 10 into 10 pi r square, right? So 3.1416 into 10 into 10. And the answer is 314.16 meter square, right? Now, don't take my word for it. I would suggest you do these calculations parallelly, all right? The next question that you need to ask is, how many trees do we need to offset the CO2 emissions released from a ECBC compliant building? So remember, it was 102,625 kgs CO2 emissions, right? So all you need to do is divide 102,625 by 21.8. And the answer, very simple, is 4,704. So you need 4,704 trees to be able to absorb the carbon emissions from a bare shell of an ECBC compliant building. Remember again, I have not gone into air conditioners, I've not gone into plumbing, I've not gone into electricals, I've not gone into interior finishes, I've not gone into stonework, nothing of that sort. 4,704 trees. The last question that I need to ask you is how many acres of trees does that translate to? It's very simple actually. 4,704 into 314.16 is equal to 14 lakh 78,291 square meters divided by 4042 is equal to 366 acres. Let that number sink in. It takes 366 acres of dense forest to absorb the CO2 emissions from the embodied part. Now, a lot of you are very smart. A lot of you know that there's a difference between embodied energy and operational energy. I'm not talking about operational energy here. You who are smart enough and have read enough on green buildings, you would know that there is a difference between embodied energy and operational energy, right? And operational energy, if you see the studies, the research reports on the internet, you will see that the ratio of embodied energy to operational energy varies. It could be as low as 10%, it could be as high as 70%. Now, why would it be as high as 70%? Well, it depends. It depends on how large the electrical systems are or the installations are in your building. If you have a very highly air conditioned, very energy intensive building with huge pumps, primary, secondary chilled water pumps, and your water pumps are really huge, and your fire pumps are all in place, and you've got motors in your cooling tower, you've got motors in your lifts, you've got motors in your escalators, for example, a mall, then you're talking about huge percentage of operational energy. But broadly, internationally, we say, okay, 30% is embodied energy and 70% is operational energy. But we don't realize that if I was to take 366 acres as only 30% of what is required to absorb the carbon emissions, then it works out to 1,000 acres of land that would be required to absorb the operational energy. Now, there is one caveat over here, which you might have caught by now, which is that the carbon emissions are the emissions during the construction life cycle of the building, not the operational life cycle. The operational life cycle, since the operational life cycle is spread over 50, 60, 70, inshallah, 75, 80 years, we could reduce that 1,000 acres to maybe around 500 acres or maybe around 400 acres so that that carbon emission happens over the life cycle of the building. Because if I was to, if I wanted to absorb all the carbon emissions in 1 year, then I would go up to 1,000 acres, right? But for the embodied part, that embodied energy has happened. The carbon emissions have happened. So I do need to install that large an acreage for the trees to be able to absorb the carbon emissions that have gone into the environment already, right? Who's doing these calculations? Who's doing these calculations for any of the construction that's happening anywhere in India? In fact, nobody is doing these calculations. Recently, I was doing a workshop for some Japanese students, and I asked them, do you know what is the annual CO2 emissions for Japan? And they obviously they googled it very quickly and they gave me the answer that, oh, it's so many million tons of CO2. And I asked them, can you tell me how many acres of forest would be required to offset the carbon emissions? They realized they needed 4 times the area of Japan to absorb the CO2 emissions, the annual CO2 emissions from Japan. What does this help us understand? Well, not much actually. That's exactly what I wanted to show you, because it doesn't create a picture in my mind. I'm an architect. I'm quite visually oriented. So here's what I'm going to show you. I'm going to show you gold. I'm going to show you work that was put together by the students of the School of Planning and Architecture in the lockdown semester, last semester that is, and just see how they tried to translate that number of 150 square meters into 4 floors. I didn't mention that. We are talking about a typical Delhi kind of development, which is tilt plus 4. So 150 square meters built up per floor is about 600 square meters total built up. And the floor is normally where the parking is. That's how the plotted development in Delhi happens mostly, right? So here's the work of some students. Here is Sukhvinder Kaur trying to show you that that little teeny weeny square that you see on the bottom left corner of your screen is the area of the plot, and the rest of the square is the amount of area that's required for the offset. Here's another brilliant solution by Tarun Karthikeyan. You can see he's equated it to the area consumed by the camera on a cell phone, and then he's saying you need 80 such cell phones to be able to offset the carbon emissions. This is Ganesh Anand. That little red dot is the building, and then you've got the amount of acreage that you need for absorption as the bigger circles. This is Satar. Again, you can see what he's done here. He's tried to equate it to the state of Goa, and he's saying that the amount of land that you need to offset is that little yellow square that you see in the center. But if you were to equate 366 acres to the state of Goa, and then you looked at how much was built up, it's that little yellow dot is how much is built up. So these were the literal ones where students have actually done calculations. All right. So look at this one. This is again by Sukhvinder, and you can see that that little fish is the area, and the larger ocean is the amount of area that's required for the absorption. Then there were some that were metaphorical, right? So we all know the tip of the iceberg situation, that 90 or 95, I don't know the exact percentage of what you see of an iceberg is below the water. So Ritesh showed it like this by saying that the problem that we are looking at is this, whereas the real problem is that big below. And this was by Joanne, again using the iceberg metaphor. And then there were some that were even more metaphorical, where the building very clearly shows that it just outweighs the amount of green that you need. And some were just outright artistic, like Ivana created this one, where that little blue dot in the center is the building, and it's just a huge spiral of green that needs to be created around it. And some were more 3D, like this one by Ieshika. So you can see that she's volumetrically tried to show that there's this little building, and then volumetrically you need to make so much more. Danish came up with this one, green building and illusion. Yes, green building and illusion. Sometimes we just need to stop building. And there are a lot of people who've spoken about this, limiting the growth of cities, from Albert Bartlett to Garrett Harding, to the MIT group on systems thinking, the guys who wrote Limits to Growth. A lot of these people have spoken about this, that it's about time we stopped. Really do a reality check. How much water does a city need to sustain? Where does that water come from? How much electricity does a city need to sustain? Where does the electricity come from? And to be able to actually create a sustainable city, and not something that's struggling or bursting at the seams, whether it's in terms of women's safety or children's safety or crime or energy and resource consumption. Shweta came up with this one, phenomenal representation. It's just showing you human values. So greed, indifference, irresponsibility, losing resources, deforestation. And behind that, you need 300 acres of forest. And what's sitting in front of you, that little 600 square meter building that we're interested in building in and designing as architects and building as civil engineers, so on and so forth. Ashna came up with this one, carbon footprint, right? Yeah, that was a two-part series. Then Mukul came up with this one, caution, green building ahead. Quite blatant. And then, of course, I had Mukil come up with this very interesting film. Um, if this is a football field, then if that football is the building, then this is the whole size of the amount of green cover that's required. And one more film that I would like to show you is this one, which was made again, I think, by Ashna, or maybe it was somebody else. I'll just tell you. So these are the materials that we analyzed. So you'll see that the global warming calculation over here varies, because this building doesn't have a 40% window to wall ratio. I'm guessing that this building would have somewhere around 18, 19% window to wall ratio. Yeah, Chaitanya created this one. So wasn't that phenomenal? That like the end frame. Let me just show you the end frame again. It's just so beautifully done, where you get to see how the building just gets lost in the amount of green cover that we really need to be able to absorb the CO2. So I just wanted to put it out there. This whole thing that we are dealing with right now about oxygen shortage, it's much bigger than what we are dealing with right now. It's not as small and immediate as we think it is, because everywhere across the world we've got systems that are consuming oxygen and giving out carbon dioxide, but the systems that generate oxygen are being destroyed as we speak. So for example, during the lockdown, second lockdown, you may not be aware that Similipol, which is one of India's largest bioreserves in Odisha, has been burnt. The forests of Uttarakhand straight 6 weeks on fire. Previous lockdown, Amazon. I don't know if you've ever gone and tried to set fire to a tropical wet evergreen forest. It's next to impossible to set fire to a tropical wet evergreen forest. They've been set on fire. The Australian bush was set on fire. California has been experiencing forest fires. So we are systematically setting fire to the largest bioreserves that the world has, which are the richest sources of CO2 absorption and carbon emissions. And we think that planting trees would really help. It doesn't. Planting trees doesn't help for a very simple reason. Um, if you look at the rate of growth of a tree, and there are only two research papers that we found on the net, one from Indonesia and one from US, that have been able to actually quantify and equate how much CO2 absorption can a tree actually have. Both of them say that the older the tree, the larger the canopy, the more the CO2 absorption and the more the oxygen generation. So if you're planting a tree, you got to realize that any large canopy tree that you plant is going to take at least 10, 15, 20 years to come to an appropriate size where it can actually contribute to carbon absorption. So if you're saying that, oh, I'm going to plant lots of trees in compensation for what I'm burning down right now, no, it's not likely to work. That's wishful thinking. Forests don't work the way we think they work. Forests don't just work in terms of trees. Forests have a lot of biodiversity, a lot of bacterial diversity, a lot of animal diversity, a lot of herbs diversity. And there's no country other than India that can understand that best. We've got systems, we've got a Ministry of Ayush, we've got systems such as Unani, Siddhi medicine. All of them rely Ayurveda, they rely on forest produce, they do not rely on monocropping agriculture. And unless we don't increase our dependence on these kind of systems and cash in on these kind of systems, we will keep copying the West and keep destroying what we have as the biodiversity that we have, the rich cultural heritage that we have, the rich natural heritage that we have. We've got to start reviving faith in ourselves. So the question is green really green? So a little background about us. We are an organization called Swaraj, largely founded incidentally by architects, but also a few lawyers, a few civil engineers. We work on supporting local people to revive faith in themselves. A large part of reviving faith is to do these calculations, the uncomfortable calculations that we just showed you, that most people don't end up doing. So we've got calculations to do with water that are very scary, calculations to do with vehicular fuel emissions that are even scarier, to be able to wake you up. Because I think that we're all very, very peacefully sleeping. And I hate to say this, but we are taught environmental science in school so badly that in whatever interactions, we do a lot of work with school students. We have been working with school students in amongst the best schools of India for a long time now. We also work extensively with university students. By the time school students come to 12th class, they hate environmental studies. They don't want to touch it with a barge pole. We've done surveys going into hundreds of school students. Very few students want to get into environment related um, professions. Very, very few. So that I'll serve for another time. I'll reserve for another time. But I did want to highlight these 5 things that we work on in Swaraj: Bhasha, Bhojan, Bhesh, Bhavan, Bhajan. In English, dialects, diets, dresses, dwellings, and dances and songs. All these 5 elements change with soil. And I want you to know that the National Building Code might tell us that we have 5 distinct climate types in India. We don't. We have 150 different soil types in India, and soil changes with climate. If you study soil sciences, the formula for science for soil is CLOT: climate, organic matter, relief, parent material, and time. Relief means topography as well. The first thing is climate. So wherever climate changes, soil changes. Now, if India has 155 soil types, broad soil types, I'm not talking about micro soil types, then these five elements, bhasha, bhojan, besh, bhavan, bhajan, will change with every soil type, which is why in Hindi we say kos kos par pani badle, do kos par bani. Every 4.5 kilometers, the water changes, and every 9 kilometers, roughly 9 kilometers, the language changes. All those languages that we are now kicking aside in favor of foreign tongues, including the one that I'm communicating with you in right now, are not capable of preserving sustainability and cultural heritage the way we have had in India. And unless we don't work really hard in transforming our perception towards ourselves, we can be rest assured that the future is not green. Yeah, that's it.
I have a couple of questions before we close.
Yep.
One would be if you had to pick a project that you were involved in, which embodies all of the green principles that you believe in, what would it be and why would you pick that?
Okay, so in hindsight, I would give this question a different answer. One, I would say that I have not yet worked on my greenest project. It hasn't happened. I must pay due respect to my dearest friend and guru Saurabh Phadke, who's currently based in the UK. But he's the one who taught me the fundamentals of building with mud and pure earth. Like, I'm not talking about lime stabilization. I'm not talking about cement stabilization. I'm just talking about raw earth, the way people build in the villages in a lot of tribal areas and in village areas in India even today. Right. So I haven't had the chance of working on that, but two projects that do come to mind that I would like to highlight over here. One is Krishi Bhavan, which was built by, designed by Studio Lotus, but designed in a very, very integrated design approach kind of manner. It took us many months, like about 6 months, to convince the local government in Odisha that they should allow us to design and build a building which is non-air conditioned. It was unfathomable to them. They could not figure out for the life of us why we were crazy. They couldn't figure out why our brains were in our knees. And they just couldn't understand how a building could be non-air conditioned. Now, if you come to think of it, it's very easy. Your own home, man. What, do you live in a house that's 24/7 air conditioned? If I was to think that this webinar reaches 1,000 people, I would say out of those 1,000 people, there might be 50 people whose houses are 24/7 air conditioned. But the rest of them are 95% of the people live in houses that are what we call mixed mode ventilated. When you feel hot, maybe at night you turn on the air conditioner for a little while. If you're sensible, you turn it on with a ceiling fan, which most people do these days. But here, what we were trying to propose is that given the climate of Bhubaneswar and given natural ventilation strategies, given thermal mass effects, given the kind of science that we have these days in simulation, which is not an exact science, but nonetheless we can use it, we can design a building that is zero air conditioned. So finally, they did give us a letter of approval on a letterhead with the national emblem on it. It was an official letter. We loved that we got that letter from the government because it said, you as consultants, and we had to sign this undertaking, promise that the indoor temperature of the building will never exceed 35 degrees Celsius. We were laughing. We were like, 35 degrees Celsius is not going to go. It's not going to go that high anyways, because if you create a building and anyways you're shading yourself from direct solar radiation, the temperature difference, perceptible temperature difference for human beings, is in that range. So we were quite happy with that. But what we managed to deliver, we were even happier about, because the local authorities, the people who were occupying that building, went ahead and did their own analysis and kind of audit of their building. And the next time the lead designer, Amrish, and Sid went to meet the head of the Krishi Bhavan, he just slapped this study report on the table and said, we've studied the building ourselves. And really, like, they almost had a heart attack sitting on the table, wondering what's going to be in the report. But the report actually was better in terms of performance than what we had anticipated. So that's one building. You guys should Google it. It's absolutely phenomenal. I quickly wanted to give a shout out to the team, Mr. Modgil, Gyan Modgil, absolute genius, MEP consultant, and Khushbu, his daughter. Amazing people. MEP consultants saying that a building can be naturally ventilated, like unheard of, right? But he was one person who drove us up the wall in terms of simulations, but also drove a lot of the decisions that went into the design. Love Chaudhary, who was then a part of the Lotus team. Of course, Amrish Arora, Siddharth Talwar, and the entire team that was working on Krishi Bhavan. Even the structural engineer, Maksudji, if it hadn't been for all these people coming together and working constantly in charrette mode, not just once, but like over and over again, that design wouldn't have happened to the degree it's happened to right now. Second project that I wanted to flag is a project that's under construction right now. My friend, my buddy Siddharth Jindal, his brainchild, Dada, the architects from Gurgaon, again, very powerful in the way they've articulated it. Hunarshala team from Gujarat did the construction with rammed earth. So it's kind of like a hybrid structure. Most of the massive walls are all rammed earth. Then there's infill walls, and only the roof slab is made out of RCC. And that in that case also they're using, the shuttering wood that they've got. They're reusing it in the interior furniture, and they're just trying to close the loop. And the one thing that we are really proud of that we are targeting in that project is to close the loop on everything. So water, how much can we harvest, how much can we use, can it be done entirely on site? Energy, can it be generated on site? Hot water, can it be generated on site? Wastewater, can it completely be recycled and reused on site? So everything closing the loop. Of course, it's possible in a peri-urban area because the site is like 14 acres and there's very little built up on it, because he's also planning permaculture as a way of life on that farm. Huge trees, fruit trees, large canopy fruit trees, combined with shrubs, combined with permaculture, organic agriculture, right? So that's the intention of that farm. So I think that project would be like really really close. Even though I forgot to mention, Aditya Advani, the landscape consultant for Krishi Bhavan, has planned the landscape in Krishi Bhavan also in such a manner that we've got rooftop gardens, we've got a dense foliage in the north side of the building. Yeah, so it's about all these people coming together with a commitment for sustainability, and us being able to facilitate that process to deliver buildings that over and over again can explain things to the world in a different way. Now, there's one thing that I did want to highlight over here, since you asked this question. Krishi Bhavan has won maybe about 10 or 15 awards by now. The World Architecture Forum Citation, RIBA Award, Design Award, you name it, a lot of them. But I still remember when Amrish went to make the presentation for the World Architecture Forum Award, it was ridiculous. We were trying to put together a presentation to explain to the European and North American community that 32 degrees Celsius with 40% RH or 50% RH with a ceiling fan at the speed of 5, which would give you a wind velocity of anywhere from 1.5 to 2 meters per second, is a condition that people are okay in. Why do I need to explain myself to the West? Why do I need to explain myself to Europe? They've been living in India for 250 years. They came and built architecture in Lutyens, Delhi. I'm an army officer's son. I lived in cantonments all my life. Those buildings were built by the British. They understood the Indian climate. They knew that it was really hot over here. They knew they had to build thermally massive walls and very high ceilings and have lots of cross ventilation. They know that. Why should I need to go and explain myself again and say that we can build green buildings in India that are naturally ventilated, because people have a thermal comfort threshold that is higher than uh, ASHRAE 55 or the PMV PPD studies? Why do I need to do that? I don't see the logic of that. We are 1.2 billion people, for God's sake, right? So I think those are the two projects. But I did want to share the nuances of these things that we are just so uncomfortable with in accepting ourselves. We just look at ourselves as if we are like like dirty, lower kind of category of people in comparison to the West. We don't need to do that. We really don't. We've got it going, and we don't have it going because of of course there is a role to play here, but we don't have it going because of Modi ji or because of Gadkari ji. No. We have it going because of us. And we need to remember that, because that, if you can remember that, then all the projects that you develop in future will be exactly like these. There wouldn't be any difference, you know. Yeah, I have verbal diarrhea, so you have to stop me.
So, with all of these green ratings that we have in the country, is enough weightage given to the materials that are sourced from nature directly rather than the byproducts of various manufacturing processes, which also pose as green materials?
Yeah, so very good question. No, they don't. And here I would like to cite a dissertation that I guided last semester, again during the lockdown. Ashwini Kumar, from a village in Bihar, was sitting in the village, and we decided to do a analysis of three rating systems: IGBC, Griha, and BREEAM. Don't ask me. Ashwini wanted to study BREEAM. So we took BREEAM, and we took these three systems, and we said, okay, let's take a village house, okay, and fairly spacious village house, but built out of mud, right? Now, what you also need to understand is, when we talk about things like new FERTs, when we talk about time saver standards, when we say that a riser has to be 150 mm, why? Have you ever asked that question? Why? Anthropometrically, if you look at the Havelis of Purani Delhi, or if you look at the older houses in Calcutta or in Mumbai or in Chennai for that matter, they have very high risers and very narrow treads, right? They work. It's not as if they don't work. It's like you don't trust human beings. No, they'll fall. Somebody will fall backwards. That's not the case. So why I'm sharing this with you is because the houses that we studied had very spacious rooms, but the ceiling height was not necessarily 10 feet. It was, say, 8.5 feet. The staircases were not necessarily like, the amount of area that a staircase occupies in today's day and age. They were narrower, but छप्पड़ का roof, छपड़ैल बोलते हैं जिसको, right? So the roof made out of hay, and walls made out of this thing, lime plaster wherever required. And we tried to compare this, or we tried to rate it on these green building rating scales, and we realized that these scales just can't give weightage to this building, where the typical person who has built that building has sourced the materials from 400 meters around his building. And here we're talking about rating systems that say, oh, you can go up to 400 kilometers around the building and source your material from there. So I think I find it a little strange that a lot of the materials that you will find in the databases of green rating systems are very often outright not green. But there is one question that I would like to ask, if anybody is listening. These big companies that are manufacturing these materials. At the end of the day, the people working in those companies are, they're citizens of this country. They're the people who breathe the same air as I do and drink the same water as I do. And them trying to push these materials in a very clearly manner, which is a manner that is not green, is eventually going to impact their children just as much as it's going to impact my daughter. So so my question is that, how do we come together and really, like, authentically, genuinely work towards a green future that doesn't create this distinction between, Shruti, what you asked, um, a deep green material versus a fuzzy green or a shallow green material that is claiming to be green but actually isn't green. You know? Yeah, yeah. So yeah, that's in a nutshell. That's what it is. They can't. They just not. There is one system though I must mention, which is the CASB rating system of Japan. Now, when we were developing Griha for large developments, we studied CASB. CASB is a pretty potent rating system. It is capable of assessing an igloo just as much as it is capable of assessing a modern building. Uh, Maybe there's something that we can learn from there. Maybe there's something that we can learn from that system and see how can it be applied over here as well.
So much for patiently answering all my questions. There will be further questions that will come up
Absolutely,
from
most
the
welcome.
audience, and we
Most
will bring
welcome.
them to you.
दिमाग की
We
बत्ती
definitely,
questions में ही जलती है.
yeah, we definitely have a lot to ponder on after this, and I'm sure there'll be
I
more.
hope so.
Thank
I
you
hope
so
so.
much for joining us
Thank
today.
you so much. Thank you for the platform and thank you for the opportunity.